So the first part of today's lesson is a continuation from 2.3, which we stopped at example 3 yesterday. I didn't talk to you about the altitude of a triangle because I wanted you to be in the right frame of mind to do your quiz, which did not cover altitude. But I'd like to start with that today because the altitude of a triangle is another line segment you need to know about. So far, we've talked about a median, which goes from a vertex to the midpoint of its opposite side. And we've also talked about a right bisector or a perpendicular bisector. Now that's a line that goes through the midpoint of a line segment and it intersects at a right angle, so it's perpendicular to the line segment. Now the last type of line segment we're going to look at in this unit is the altitude. Now thinking about an altitude, if you talk about the altitude of a mountain or of a plane, it means how high up you are vertically. And that's exactly what the altitude of a triangle would be. So if my triangle looked like this, A, B, and C. The altitude from vertex B would be the line segment that goes from vertex B straight down and hits the side AC at a right angle. So it does not go through the midpoint of AC, it only goes through point B, but it's perpendicular to the base of that triangle. So the altitude is the height of a geometric shape, or figure, same thing. And the altitude of a triangle is the perpendicular line from a vertex of the triangle to the opposite side. So let's look at an example. The vertices of triangle ABC are -3, 4. Make sure you label it properly on your graph. 3, 2, there we go, and -4, -1. So that's our triangle. I'm going to do my best to connect those three vertices to form a nice line. A little bit rough, but we'll get the idea. Okay, so that's our triangle. Now it says determine the equation for the altitude from vertex C. That means we are going to start at vertex C and we're going to go straight toward the opposite side of the triangle and we're going to intersect it at a right angle. Now, I often find it's helpful to turn your page. In this case, when you're trying to draw the altitude from a vertex, the side that it's going to hit, which in this case is AB, you kind of want to make it horizontal so you can estimate where a perpendicular line is going to be. So if you turn your page so that this is a horizontal line, you guys can't see that I turned my iPad, but I did, and you're going to make a line that goes from C to AB, that touches that opposite side and hits it at a right angle. So pick a piece of paper or the corner of your ruler, some sort of right angle, and use that to help you. You need to make sure that this part here that you're drawing is a right angle. So the line is going to be very close to vertex A in this case. I'm going to approximate. It's going to go maybe right there. That's probably even a little bit too slanted. Let's go back and I'll change that. It's very, very close to vertex A in order to be a right angle. So that's approximately the altitude. That's the right angle shown right there. Okay. It does not hit the midpoint. It intersects AB at a random point. We don't know what it is, and we don't actually care what it is for the purpose of finding the equation. Okay. Now it says to determine the equation for the right bisector, or for the altitude. So the altitude or the right bisector or the median all has the same process to finding the equation. Any equation of a line requires you to know slope and 1 point. Every single time you're trying to find the equation, that's what you need to start with. So when you look at the altitude, that red line in our graph, what you would do to find the slope is you would have to find the slope that's perpendicular to the side it intersects, because it's the only way you can find it. You don't know the point where it matches. It doesn't meet up at a midpoint or anything that you know. You have to use the slope of AB to find the perpendicular slope that goes through point C. Point C is the point we're going to use in our equation. So we do already have that point. That's point C. We'll write that down here. That's point C. And we're trying to find the slope, and our slope is going to be perpendicular to that opposite side. So step 1 would be to calculate the slope of AB. Little m for slope AB is equal to, and we're going to use the coordinates of A and B to calculate that slope. So 2 minus 4 over 3 minus negative 3 would be negative 2 over 6, which reduces to negative 1 over 3. That's the slope of AB. Now we have to find the perpendicular slope so we can use that in our equation for the altitude, because the altitude is perpendicular to side AB. So our next step would just be to find the perpendicular slope of AB. So make sure you use the proper notation. It's requiring you to flip the fraction and change the sign. These should be negative reciprocals. And you know this because you did this with the right bisectors. Negative reciprocals. And so you're going to flip the fraction and change the sign. That means that the new slope of AB, when it's perpendicular, is going to be positive 3 over 1. That's the perpendicular slope we're going to use in our equation. So that slope combined with point C, which is at negative 4, negative 1, will give us the equation of the line. We have to use point C because that's the one that's touching the altitude. The altitude only goes through point C, and it's perpendicular to the base, so we're using our point and our perpendicular slope. Finally, we're going to put them both into the equation. Now, the equation of a line with slope and a point, we use the PQ formula, m bracket x minus p plus q. We're going to put our slope in for m, and we're going to put our point in for p and q. So y equals 3 bracket x. Remember to change the sign. This is negative 4, so in the brackets we're going to write plus 4. And the back one stays the same. Distributive property expands that bracket, so y equals 3x plus 12 minus 1, and finally y equals 3x plus 11. Now, I went through this whole question without ever checking against my graph. That was not too wise. I would not recommend that you do that. I'm going to hope that I did it right now so I don't have to erase the whole question. Regularly, what I should be doing is I should be checking every single step of the way. So when I got this first slope right here, slope of AB is negative 1 over 3, I should have said, okay, from A to B, 1 over 3, down 1 over 3, down 1 over 3. Yes, it does. That means I've done that part correctly. Put a check mark. And then I should have said, okay, does the slope perpendicular to AB go approximately up 1 over 3? Now my drawing isn't perfect. Up 1 over 3 would have gone through this point right there, but it's pretty close. It shows it's approximately the right slope. If I got negative 3, you'd know it would be going down. That would be incorrect. So that one's also correct. Now we got the equation of the line y equals 3x plus 11. How would we check that on our graph? Well, the only way to check is to imagine that that line is going to continue past the triangle that it currently sits in. So if this line segment, this red line segment, keeps going all the way up, it's going to go beyond the parameters of the graph and hit somewhere up here. So is that positive 11 approximately? Well, if we count, this would be 4, 8. It's higher than 8 significantly, so yes, that probably would work to be positive 11. So using those kind of checks, those verifications, we'll know that we have the right answer. That's how you calculate the altitude of a triangle. So you find the equation of the altitude. Now there's some questions from last night's homework that you didn't do because they were about altitude and we hadn't learned that yet. So I would encourage you right now to take a break and to go and do those questions on altitude from the homework in 2.3. It will be listed in the 2.3 homework from yesterday, and there'll be the questions that ask you for the equation of an altitude or the length of an altitude. You wouldn't have known what that was yesterday, so probably you skipped them, but you should definitely try them because there will definitely be a question on your test to do with the altitude of a triangle. So take a moment and do that, and I'm going to post the video that's coming up separate from this one here.